So far, we've only looked at ways to solve right-angled triangles. This video gives one example for how you can solve a non-right-angled triangle. The law that we're going to look at first is the sine law and an application question. What you need to know is that the largest angle in an acute triangle is opposite the longest side, and the smallest angle in an acute triangle is opposite the shortest side. What that gives us is the ratio of the side lengths is equal to the ratio of the sines of the opposite angles. So in an acute triangle, this is true, and this allows us to write the sine law. So for this triangle here, I can write the sine law as A over sine A is equal to B over sine B is equal to C over sine C. Usually we put the sides on top if we're finding a side. If we're looking for an angle, we can write the sines on top. Really, it is the same law, just written in two different ways. Let's see an example of how to apply this rule. So in triangle ABC, we're given some information here. So let's draw it out. So we've got triangle ABC, non-right angled. My angle A is 78 degrees. My angle B is 68 degrees. And side A, which is right across from angle A, is 5.9 centimeters. The side that I'm looking for is side B. So that means the two pieces of the sine law that I need are A over sine A and B over sine B. I know that I need those two because I always need one pair of angle and sides. That is my A. My second pair is going to contain the unknown quantity that I'm solving for, which in this case is B. So because I'm looking for B, I'm going to rearrange before subbing in by multiplying both sides by sine B. Now I've got that side B is equal to A sine B over sine A, and now I'm going to substitute in the values that I know. So I've got 5.9 sine 68 degrees all over sine 78 degrees. Putting that into my calculator is going to give me a value of 5.6 centimeters, which seems like a reasonable value for B. Let's look at another example. Now I'm asking you to solve the triangle. So remember, to solve means to find all the missing sides and angles. So in this case, we're trying to find three things. We've got angle A, we've got side B, and side C. Let's start off with angle A, recalling that all three angles in a triangle add up to 180 degrees. So I can use that fact to solve for angle A, and I'm going to get 85. By solving for that angle, now I have a pair of an angle and an opposite side, which is going to allow me to solve for B and to solve for C. So I can set up my sine law in two parts. B over sine B is equal to A over sine A. And I also know that C over sine C is equal to A over sine A. I used A over sine A in both because that is my pair, side and opposite angle that I know. So on the left here, in my first one, I am solving for B. So I'm going to do the same thing I did and rearrange before I sub in. So now I've got B is going to be A sine B, which is 80 degrees, and then I'm going to divide by sine 85. When I evaluate that on my calculator, I'm going to get that B is about 23.1 centimeters, which seems like a reasonable value, and then I'm going to do the same thing for C. So again, I'm going to rearrange for C first before subbing in, and I get that C is equal to A 23.4 sine 15 all over sine 85. Plugging that into my calculator is going to give me a C value of 6.1 centimeters, which seems reasonable as C is the smallest angle, and I solved for the smallest side. Now that we've seen two examples of the sine law in theory, we are going to apply it to an application question. So here in example 3, we've got a hill that has a 20-degree angle of inclination. So that means how steep it is. A tree that's growing on the hillside, so I've got a tree, is going to cast a shadow of 70 meters down the hill. So like this, all the way down here is 70 meters. And it casts that 70-meter shadow when the angle of elevation of the sun is 30 degrees. So that means that if I'm going from here all the way to the top of my tree, the angle of elevation of my sun will be from the horizontal all the way up, which is 30 degrees, which means that right in here is going to be 10 degrees. So maybe you're starting to see the triangle that I'm going to solve now. But this is my x, so I'm going to say let x represent the height of the tree, because that is what I'm going to have to solve for. Now, if I draw a sketch down here, I've got a triangle where I know this side, I know x, I know my angle here. If I knew this angle up here, I could use the sine law because I would have an opposite pair. So let's take a look. Well, if I draw a horizontal line right here, I know that on this side is 90, and I know that I've got two parallel lines, so that means this angle here and this angle here must be equal to each other. So then I know that this whole angle down here is going to be 110, and that's going to allow me to figure out this angle out here, which is going to be 60 degrees. So now I've got a triangle that I can use the sine law for. I've got a non-right angled triangle, and I've got a pair side and opposite angle. So let me label my triangle here. I've got A, B, and I'll say X so that it matches with my variable here. And I know A is where I have my pair, and X is where I have the one that I'm looking for. So I've got A over sine A is equal to X over sine X. Again, I'm going to rearrange by multiplying both sides by sine X to get X by itself over sine A. And now I can substitute in my values here. So A is 70 meters, sine X is 10, and sine A is 60 degrees here. When I evaluate that on my calculator, I'm going to get that X is about 79.6 meters.